Once again, very warm and knowledgeable good morning to one and all as we about to begin the very new session, that is day two, session one, conducted by Dr. Meera Dhabu ma'am. Currently, she is working as associate professor in the Department of Computer Science and Engineering in VNIT, Nagpur, since 25 years. Research area he has covered mainly data mining, machine learning, optimization for cyber physical systems, and he has publication in nearly 40 SCR papers in a renowned journal as well as 15 plus papers published in international conferences. Talking about the consultancy in the various organizations he has contributed her research work and developed some system for the renowned organizations in the Maharashtra like Maharashtra State Electricity Transmission. The project itself was automated meter reading AMR, meter data acquisition system MDAS, nearly cost about 100 crores. The second project was with the same organization and the title was Corporate Data Warehouse System of MTA project in MSCPCL. The cost was around 115 crores. Again, one another project that is for the Chandrapur Forest Academy and Administration Development and Management Chandrapur, and the title of the project was Smart Classroom Technology and IT Infrastructure, cost nearly 10 crores. The revamping of the website and development of the web application of MP Web CC Nagpur. She has also organized seven Asian Computing International Conference in 2014 at VNIT. Also, registration co-chair for the 8th Asian Compute International Conference in 2015 Greenland, New Delhi. Also organized 16th International Conference on Management of Data COMAD in 2010 at VNIT. Regular workshop organized by her on advanced data analytics and machine learning. Core committee members of Rashtriya Avishkar Abhiyan RAA MHRD initiative. Under the umbrella of RAA, NIT guided students and the teachers of six NLP schools in Nagpur in the area of science and mathematics. He also is a faculty mentor for triple ITS, having membership, professional membership of IEEE, ACM, IEA, lifetime membership. He also professor in charge, student mentor program, VNIT, and member of ICC VNIT. I welcome you now. Now I would like to call Professor K.D.K sir to felicitate Dhabu ma'am by giving a speech. Now I request our HOD ma'am, Dr. S.P. ma'am, to please give a token of love, memento to Dhabu ma'am. Thank you, ma'am. Now I would like to request Dr. Dhabu ma'am to please start.
Thanks a lot for the warm welcome by Mr. Kureva sir. And I don't know whether I'm good for what he introduced. That write-up was given by me, which was prepared long back. Once again, good morning to all. I'm a hardcore teacher. So I generally feel that when somebody attains everything specially, point of view, whatever is being delivered is related with what products are going on, what applications are there in the market. But as I said, I'm a hardcore teacher. I will be talking more technical than the blast. Okay, so it might happen that my talk will be little earlier from the technical point of view, the content point of view. Don't look at the number of slides. I will skip some of the slides where I try to simulate how a particular thing works when we talk about the machine learning or AI. Like next
Pointer pen.
Am I audible? I'm visible also. I mean, you can connect to me, right? Fine. No.
Hey guys, फक्त microphone साठी. Okay, fine. So once again, congratulations to all of us for the successful landing of Chandrayaan 3. And all of us are aware that many a part where the decision need to be made and action to be taken is designed using the AI. So this is the classic example of made in India product where AI is used and the landing of Chandrayaan 3 was fully automated. No human intervention was there. And we are proud to say that yes, we, especially the scientists from ISRO, did the great job and we are proud of them also. And there are many other examples if we talk about Vikram lander and many other technologies they have used, especially for the space research. Just again, this might be a revision for you, how the AI is evolved over the years. Before, I mean, in the towards the mid 18th century, the AI was introduced. It got matured towards the early years of the 19th century, and when it comes to 1990, the ML terminology started becoming very popular. But before ML terminology comes to the became popular, the ALM was there from the early 90s. Then from 2010 onward, especially the paper published in 2012, the deep learning was the most popular terminology amongst the engineers, especially computer engineers. But if you look or if you hear the videos of like Sundar Pichai, he used the term AI. But when the recent years, when anybody used the term AI, it is not the conventional AI in which the symbolic manipulations are done. It is more or less deep learning, which is a higher version of the artificial neural network. So now this, everyone knows, AI is a very big umbrella. Inside that umbrella, it covers the machine learning techniques, and then inside that, again, there is a subcategory that is a deep learning, which is an extended version of the artificial neural network, and of course, a data science. A data science is having an intersection between all three, that is broadly AI, in that ML and DL, and otherwise also we do study some statistics. So what is AI? It is nothing but when the conventional computing was well established in early 90s, during that time, the researchers realized that the way human brain works is quite different than how we try to do a programming in the conventional computer. So can we develop a system which will, where by design itself, it will try to mimic the human behavior or human intelligence? And then when we talk about the conventional programming, when I say conventional programming, I'm typically talking about the problem statement which are thoroughly understood by us and for which we can write algorithm. And there are most of the problems in the real life which are not so simple. They are very complex beyond our understanding, where we cannot formulate any formula, cannot formulate any logic, and hence research is required to investigate that how human brain works. And by looking into that, they started designing the new algorithm, and that comes into the as a branch of machine learning. You can differentiate the behavior of a kid and behavior of a grown-up person. So the difference majorly is in terms of the experience. So can we develop an algorithm which will design another algorithm by looking into the data? That is the main motive while designing any machine learning technique without formally programming that solution to that problem. How it works. So data comes from the experiment or simulation, depends on what. When the data is collected, the data is pre-processed so that it can be used for the machine learning, and the database of that data is created, which is a clean data. Now there are many algorithms. Here I mostly focus on the machine learning algorithm, that is deep neural network, artificial neural network, maze-based, then RBF, basis functions, LSTM, and RF, random forest. Then using these algorithms, we design some models. Mostly those models are data-driven models. That is, that model gets developed with the help of that data. And then we can design applications, and the categorization of an application can be optimization, prediction, or classification. Okay, before going to the next slide, what this means is we need some data to be collected, that data to be cleaned. I will not talk much about the data cleaning. I hope the data is coming from some system from the outside world, and that outside world is not very ideal environment. It might be having a noise, or if you are reading the data from the sensor, it might happen that because of temperature, sometimes the sensor is not giving the correct data, it might be giving a noisy data. Okay, so there are many reasons why you get noise or outlier in your data. So after pre-processing, after normalizing the data, you have a database. Now we design a model. Physical system is one thing, or simulated data is one thing, and the model which we design using any ML technique is a model, is not the actual system. So model will be always approximation of the existing system. Okay, that is why in most of the books you will find that it will say approximated, okay, or estimated model. So model we never expect that model should perform 100% accuracy. As we are saying that it is an approximation of the existing system, it will try to mimic the behavior of the system, behavior of any other environment. Now, once it comes to the model, when I say model, so we model how I can build a model. Okay, but is it so that while studying the engineering and so we are developing a model? No, we started designing the model right from the childhood. Right? I will not go very as a toddler, but as a kid going to the pre-KG, say nursery. Okay, in nursery, teacher first teaches us few alphabet letters, which is the language. Then they will introduce us 1029 single digit number. Then they will introduce us to two-digit number, then three-digit number. Once they start introducing us two-digit number, parallelly they will start teaching us some additional mathematical. Okay, so it is not the case. So it might be the case that in KG2 they might have taught us how to add two numbers, two single digit numbers. As we as we go to the higher and higher grades, they started increasing the difficulty of the same operation. Yes or no? Okay. So why they taught us this? My question is, have we done or have we developed any model before entering engineering college as a student? No? Most of you say no. I say yes. Now I will no, justify my stand. For example, mother wants to host a birthday party for the young elder one. Okay. So of course, if she wants to host a party, birthday party, she will say, how many friends would you like to invite? Then there is a younger one, younger sibling is also there, that my friend should be invited. Okay, there is always no tussle that so mother say, okay, I will accommodate your friends also. So the elder one says, I would like to invite my 8 friends. The younger one says, I will invite only my close friends and I have only 4 close friends. Okay. So what mother will do, how she will calculate the total number of guests to be expected during the birthday party? 8 plus 4. What we did actually, what mother did, why these formulas were introduced to us in pre-KG or first standard? We develop a model. Mother develop a model where the real statement is what? Number of guests invited by the elder one, the number of guests invited by the younger one, and she added that. So it is not the case that we have not done modeling. We done modeling right when these mathematical instructions were introduced to us. Not only that, we have been introduced to physical equations, mathematical equation for physics. Okay. For example, in first year, electrical engineering, basic electrical engineering, so many times we wrote RLC circuits equation, isn't it? One type of RLC circuit was taught in the class, little bit variations. So that relationship between RLC was taught to us. What is that? What is that? The one who introduced that equation, who understood the relationship between RLC, okay, and expressed it in a mathematical way. That mathematical equation is nothing but a model for that circuit. Why? Because institute cannot afford giving the resistor, induction, conductor to each and every child and vary the values of those and change the current and voltage and measure it. No. So what they did to make the student understand, we are blessed that some scientists did great job. They developed the mathematical model because they understood the relationship between RLC and the voltage and current. If I change R by this, how the voltage will change, current will change. That is made us understand by that equation. So ultimately, the model is what? There is a system, some input will be given, and what will be the output. Okay, so not why I am discussing this, because I want that one should not get afraid that what is modeling. Okay, especially in terms of ML. So the definition of model is simple: a representation of an object or a system or a process or some idea also in some form or other. Then it will be always abstract of the reality. Okay, as I said, electrical physical circuit is one thing, and writing the mathematical equation is another thing. Okay, so we are representing that physical electrical system with the help of mathematical equation. Then miniature systems are also very popular. That is another way. So there are three different ways of constructing the model. Physical model, as I said, miniature model. Second one is the mathematical, which I said we write equations for various electrical, electronic circuit or mechanical. If I want to compute some no, RPM of some machine or something else, or in applied mechanics stress given the pressure and column and dimensions of everything, civil construction, what will be the stress at that point? Okay, so those are calculated with the help of mathematical equation. Now let me tell you, physical is very easy because you are building a physical system. Okay, so you are taking the, I mean, you have a physical system which into which you can see it. Mathematical system, difficult, but mathematical system can be designed, or mathematical model can be designed only for those systems in which one has thoroughly understood that if the input is this, output will be this. If that is very, very clear, then only one can write a mathematical equation. One can represent that system mathematically. If the system is very, very complex, beyond our understanding, the number of variables, the complexity of the system is very high, it is not at all possible to express the relationship between input and output with the mathematical equation. Okay, and there the ML techniques comes to our help. And simulation, everyone knows, pilots are not trained on the real flight initially, they are trained on the simulation. Or video games is the best example of the simulation. Okay, it gives the illusion that you are into that environment and you are driving a vehicle or you are fighting with. Now, this, if you understand developing a model, the stages of the model, then it will be very easy for you to come up with any model. So there are two steps. System identification. One is given a problem, whether I should go for the conventional programming, whether like if somebody asks me to develop employees payroll software, there I don't need any AI because I know basic itna hai, itne percent mein DA rahega, HRA will be this much percent, another allowances will be this much. So I know what is the relationship between the input and output parameters. Okay, input parameters are called independent parameters because they are independent of any other variable, whereas dependent output is a dependent variable because the value of the output depends on the input variable. Okay. Again, whether I should go for fuzzy logic, genetic algorithm, ANN, deep network, or some another optimization technique. Okay, if you could identify that, it is called structure identification or system identification. After doing the system identification, one can go for the structure identification. Structure identification, if I go for say ANN, artificial neural network, then what should be the input? How many inputs should be there? How many hidden layers should be there? How many neurons should be there in the hidden layer and the output layer? So the internal design of the system is nothing but structure identification. That is also a little easier part. System identification is very easy if you are working in that domain. Then structure identification is also little easy compared to the parameter identification. Compared to the parameter identification. Parameter identification is the toughest job. And today, whatever the research is going on, the majority of the research in machine learning is parameter identification and not any other aspect. So what is parameter identification? Given a system, input cannot be changed, output cannot be changed in the database. We want some algorithm, we want to find out some model which will map given input to a given output. That model is unknown. That model is unknown, and that model is characterized by the free parameters. So if you look at the first equation, y is equal to ax1 plus bx2 plus cx3 plus d. So a, b, c, d are the free parameters. Why these are called the free parameters? Because we can adjust the value of these parameters so that given the input vector whose individual element is x1, x2, x3, it will generate the output y. Got this point? Okay. Now, if the relationship between the independent parameter, that is input and output, is very straightforward, can be represented with a linear equation, we can say that it's a linear system. There we don't need to apply any AI or ML technique because that relationship is simply understood and you can express it with the help of mathematical equation. Okay. Whereas in the second one, y is equal to ax1 cube plus bx2 square plus cx3 plus d. It's a little complicated, having a higher degree of equation. Such systems are called nonlinear systems. Okay. In that also, till quadratic, one can understand the relationship between the independent and dependent parameter and can express it with the mathematical model by writing the mathematical equation. But there are some systems which are very complex and cannot be understood. Okay, there you should think of making use of any ML technique. I hope everyone is with me. Okay, a very simple example is price of a used car, and attributes are, X is a car attribute, that is independent variable, and Y is the dependent parameter, which is price. And G is the model here. Theta is again the set of parameters, that is free parameters. Okay. So here you can see, if you plot X versus Y, you will get some line. So I can say that, fine, it is a linear system. I can build a linear model to express the relationship between X and Y. Okay. Now here, one more point I want to press here is, given the value of X, you need to predict Y. Okay. This is one application of ML. What is this? This is nothing but regression. Okay. This is called regression. We conducted many workshops and we have been motivated by our head and the professor from VNIT department, that is Professor P.S. Deshpande. Part of the slides I have taken from that workshop itself, which we conducted together, and most of the contents of first part of this presentation is from this book, that is Statistic for Management by Levine. Very good book. So here is the outline of the first part of my discussion, that is simple regression and correlation, multiple regression and modeling, and sample problems. Prerequisite, when we talk about the data, I hope everyone is aware of what is sample size, population, and the sampling distribution. Okay. Now, do anyone wants me to repeat this 3 points? Because this is a requisition. Population, if I want to do a survey, like for the election, right? Exit poll. What they do? They identify some pockets of the society. That will be the complete population, a complete resident of India who are eligible for voting is the population. Then the section of the society which will be selected for taking the reviews for the exit poll will be a sample. Okay. And again, there, when you want to apply some statistics to the data, for variety of statistics, some distribution need to be followed. So it is understood that if we take such random samples from the given population, it follows which distribution? It follows normal distribution. Okay. it follows normal. So as I said, simple regression, it gives you the relationship between the variables, that is independent variable and the dependent variable, which can be seen with the help of scattered plots. Looking at the scatter plot, we can estimate how the regression line will be. Now, ultimately, as I said, model is an approximation and not the perfect model. It will not work to the 100% accuracy. So it will have some percentage of error. So how? Because we can have a multiple model. Given the multiple model for the same problem statement, how to evaluate those model? Which one is the best one? We need some measure of performance. We want to measure the performance. So measure of performance is required. So here we can make, I mean, I will be introducing you 2 to 3 measures of performances. So generally we use least square error method, and then we will see that how it is evaluated. Okay, few more example. As I said or mentioned, it regression is used to identify the relationship amongst the variable, and then this relationship can be used for any kind of prediction. In some of the literature, you will find that it is also called function approximation. If you look at the literature which is focusing on the ANN, uh, examples can be given the educational level, what should be the income of that person, given the weather condition, what will be the electricity demand, given the weather condition, what will be the traffic congestion level on the roads, and many more. Okay, so the regression equation is a formula which shows the trend, or I can say given the data points, if it is a linear regression, I will change my problem statement to given the points I want to fit a line which passes, not exactly, but which passes through those data points, giving me the minimal least square error. So depending on the number of independent variable, we can have a simple regression or multiple regression. Depending on the regression coefficient, we can have a linear regression or non-linear regression, and we can have a mix of above. I will skip this. Okay, coming to the scatter plot. Why scatter plot is required? Okay, let me show you the scatter plot first. These are the variety of scatter plots. The first one is the direct linear. The second one is the inverse linear. Next is the direct curvilinear. That is, first two are the linear one. Second, third is not the linear one. It is non-linear. And the next one is the inverse linear with more scattered. Sometimes it is like no compactly fitted data points. Sometimes it is loosely fitted data points. Okay. So first two examples are compactly. So take this example. These examples are from the book of Statistics for Management. So you can refer it as and when required. So given the student score of entrance examination and cumulative grade point average at graduation. So given this, can we predict if a student comes to an institute and you want to predict that how much CGPA he will secure when he or she will graduate from this institute? Okay. Next is this. So in the here, looking at the scatter plot of this data points, it seems that a linear regression is sufficient for me to design a model for this. So I will try to fit a line. I will try to fit a line. We will see that how the line is fitted using ANN. Okay, not here. So now these are the data points. If tomorrow somebody comes to me with say 92, the score of entrance exam is 92. If you look at the nine, there is no 92. There is no 92. No student is having a 92. But as we have developed a model, we can use this model and we can predict that, okay, this line will continue here. So here is the, I can project it here, and this can be the CGPA of that student who comes to the institute with the entrance score of 92. Okay, so data points are given. Some are, each and every point is not covered. Each and every point between this is not covered. Between this range is not covered. So for predicting the CGPA for those students can be done using this model, this line. Now this line doesn't come directly. It comes with a trial and error. How that comes, that we will see with the ANN. Okay, so these are some mathematical equation of line everyone knows. Y is equal to mx plus c. M is the slope of the line. This is what we studied in this school. So I am not using the same terminology or nomenclature used in this. So another is, now I will discuss about the how to evaluate the performance of the developed model. Say this is the data points given, okay, and from this data point one straight line is fitted, a model is developed. Okay, that equation of a line is nothing but a model. Okay, equation of a line is nothing but a model in AI or machine learning. Now performance measure, one method is least square error. Okay, so this is, as I said, actual data points are this, and now in this case it is the model is passing through all the data points. Okay, whereas in this case it was not. It was not. For this point it is making this much error. For this point it is making this much error. For this point it is making this much error, and so on. Okay, so as I said, model is an approximation of the system and not the actual system, so it will always make some kind of error. Yeah. Yes. Approximation. Now you look at this. Now here the y is having a hat and not y is equal to a, whereas x is not having a hat, because see, generally I give the examples to students in my classes. There is one NGO, okay, and they want to study some health related parameters. Okay, now they don't, as NGO, they need to travel, and that NGO is working for the underprivileged section of the society population. And now they, every time they want to measure weight and height. Okay, height very easily, one can carry the tape. Weight, weighing machine, not very easy to for portability. And those volunteers might be coming directly to the that society section of the society. So if you have already collected a data, and if you have a regression model with you, that is the equation of a, now when you go for the survey to another area, you don't have to carry weight weighing machine. You just carry a tape for measuring the height. You have a regression model, put the height and get the weight. Got it? Okay, it is something like that. So we want, and now that will not be exact. You did a study of one section where you measure the height and weight physically, actually, and then you develop a model. So the input is correct. Input is correct, but whatever output is, it is an approximation. That kid might be having a height little bit more or less. That's why this approximation is shown or the estimation is shown with a hat because it is an estimation, okay, and not the actual value. So now, as it is an estimated value, the actual value is y, the desired value is y, but your model, that regression line is giving you the value y hat. So there is a difference. Not all the points, data points are on the line of regression. Okay, so it is giving you some error. Fine. Now, so these are, for example, this is the case. These all are the data points. Now, this is the actual data point. Your regression model giving this equation of a line. Now, this point is making this error. This point, sorry, this point is making this error. This point is making this error. Okay, your regression is an approximation, estimation. Now, if I add, this is a similar example, only different angle of a line. Okay, this is the inverse slope, this is a positive slope. Now, if I keep, it's giving you error. Error means what? Desired value is y, and your model is generating y hat. So difference between y and y hat, that is y minus y hat, will be an error. Okay, if I add those error, what will happen? What will happen? Two errors are plus 2, and one error is minus 4. So actual error will be what? 0. What kind of impression it is passing on? It is a perfect regression. Is it so? Is it so? No. It is making error with these data points. And why it is happening? Why we are getting 0 error? Because positive error term getting nullified with the negative error. Okay. So what is the solution for this? So in previous case, we have taken the absolute error, the true error. So we can take absolute error also. Absolute error, remove the sign. Remove the sign. Okay. So in the first case, it will become 8, and in the second case, it will become 12. Now my minus 4 become plus 4. So 2 plus 2 plus 4, it will be 8. Now I can say that the performance of my regression model is evaluated with the help of absolute error, and the absolute error for that model is 18. Okay, I hope everyone is with me. So instead of absolute error, it is always better to take sum of square of error. Sum of square of error. So instead of 2, it will be 2 square, 2 plus 2 square, plus minus 4 square, it is 16. Okay, so 8 plus 16. So that is this. So always remember thumb rule. Total error, that is the actual true error, should be close to 0. Why? Why? No, it is not a perfect line. We are talking about the true error. But still we are preferring that if the true error is 0, then we should further investigate that line, that regression model. Why? जितना पॉजिटिव एरर हो रहा है उतना ही निगेटिव हो रहा है, वो सब पॉइंट्स को बैलेंस कर रही है लाइन, बीच में से जा रही है, कहीं वो बहुत नीचे नहीं है, कहीं वो बहुत ऊपर नहीं है. Got the point? Okay, so that's why some weightage is given towards the value of the true error. Okay, so that is why they said total error should be close to 0. I'm not saying it should be 0, it should be close to 0. Second is absolute error does not stress on any magnitude of the error. We should not look into it. But sum of square penalizes large error. Okay, wherever there is a large error, it will get again enhanced. The magnitude will be again enlarged, increased. Okay. So, and of course we are squaring. So positive is going to remain positive and negative will become positive. That is another thing. Fine. So coming to the next part, the second part of this presentation is on the artificial neural network. From where the motivation we got, I mean, the researchers might have got the motivation. We know many a task in real life we do very easily. Most of you might have traveled either by four-wheeler or two-wheeler to this location. Looking at the Indian road condition, okay, there is a pothole. Have you calculated exactly how much distance it is there from that pothole to the current position of your vehicle? Based on that, have you calculated how much pressure you have to put on the brake and then the clutch and when to change the gear? Have you? Okay. Beautiful design, right? Beautiful design by God. We never thought about this daily life. No. Right now, I'm talking to you. Might be thinking, I missed my class. What student might be doing? I need to cover my course. Many other things. Okay. So there are many tasks which we do very easily. But if you want to get the same task done by the machine, it's very difficult. Very difficult. Okay. So that is what, again, what I said, I will repeat. In early 90s, researchers realized that the way our brain works is different than how they have started designing the conventional digital computer, how they started designing the algorithm for solving the problems which can be expressed either with the logic or with the mathematical model. So they realized that we need to think differently if we really want to mimic the behavior or the way cognitive behavior is there from the human being. Okay. So most popular thing is the pattern recognition. If you go to watch some movie and some students from your college is there, you will identify. You might not recollect the name of the student. This is the crowd of VNIT. Okay, I will recognize. Why? So much patterns we are seeing daily, but still we could recognize. Okay. So pattern recognition, audio processing, video processing, these are the tasks which we do very easily, which cannot be done very easily with the help of computer. And of course, as I said, the distance from that pothole to my vehicle is not very accurately measured by my brain. My input is noisy, incorrect, or partially correct. There might be some another vehicle, okay, going through that pothole. So complete data is also not receiving to my brain. Still, I could reach safely to this point, to this location. Okay. So that is ill-defined, experience-based, and so and so. So ANN is, I said, it is designed after the brain, where learning is the predominant feature of the brain. As I said, there is a vast difference between the understanding level of a kid and understanding level of the grown-up. I generally give the experience example to my student that you people are sitting in my class. I'm teaching this course from last 16, 17 years in my institute. So you are teaching here in CSE department, registered for soft computing technique course. Okay. You are exposed to what I'm teaching you. At the same time, your fellow friend from the mechanical department might be attending a course in machine design. He is taking a class, he is exposed to that environment, you are exposed to the aesthetic environment. If I, on exam day, if I ask you to write an exam for your friend and your friend to write your exam for aesthetic course, will you be do it? No, because that environment is not provided. And from that environment, the experience is gained by that student. The knowledge is nothing but the experience. If one is not exposing that element, that student is nothing but element. is not exposed to that environment, how the experience will be gained? If experience is not gained, how that circuitry will be developed inside the brain? Before we take, most of the student has never studied neural network, we will assume that. Okay, before coming to this course, he was not exposed to the neural network, that environment was not provided, so he was not aware of anything about the artificial neural network. Okay, so that is what the learning means here. Okay, so before going into the details of ANN, few highlights of the applications of ANN to keep you hold it. Very popular one, driverless car. How much lessons we took for driving a four-wheeler, two-wheeler? Hardly 4, 5, 6. Okay, and how much time the scientist is taking to design a driverless car? Years, years. Okay, so here, try to understand data processing, capturing the pattern, identifying it is done with the help of AI, that is deep learning or ANN, whatever you call it. But ultimately, controlling the machine will be done by fuzzy logic. So that input, whatever is being data is inputted through the sensors to the system will be processed by AI, but ultimately control action will be taken by the fuzzy based system. Okay, so don't mix it. Each technique is having its own domain of applications, and here many domains are combined. I mean, in most of the application, you will find that many domains are combined. So neural network is popularly known to be used for the application where pattern recognition is there. When I say pattern recognition, it can be an image, it can be a video, it can be audio, anything. Okay. Like if you want to develop a product for a close CCTV circuit, for example, your campus is having a very controlled gate, okay, where entry and exit of every vehicle and human being is tracked. And if some biker came, he hits some student and he run away. And you want to stress it. Assume that you have a CCTV at every location. It is capturing each and every corner of the campus. Then the video will be dumped. Then what you will do? Where the accident occurred, identify the structure of the color of the bike, or if it is possible, the number plate of the bike. Okay, and give to the system that press this number plate where it is moved through the campus. Okay, so what pattern you have you ask machine to extract? Number plate, color of the bike, type of the bike, or the shape of the bike. And then to the rest of the video, it will try to recognize that pattern, visual pattern throughout that video. Everyone will appreciate this. Okay, understood this? This is what the pattern recognition. I mean, buzzwords are there, but actually we should always keep linking it to our real life applications. Now, we are generating so much of data. Everyone is carrying mobile, right? Everyone is carrying mobile. Earlier it was not so. Fine. And where this data go? To some data center. Okay. So, okay. I forgot to mention about the characteristic of the human brain. I will come back to that. So now, depending on the exposure, depending on any in the data centers, the data is stored in racks. I mean, the red disks are stored in the racks like a cupboard. Okay. Now, it might be thing as somebody might be processing data or retrieving the data from a particular hard disk. So, of course, the processing going on, the heat will be generated there. So heat will be, so other than any other corner, that corner of the data cooling center requires more cooling. Okay, so which the temperature of each and every corner of the data center, which corner requires more cooling. So if you want to automate, that can be done with the help of AI applications or popular use of artificial neural network is image processing, computer vision, that is video speech recognition, and so on. So this is another one. Towards the end of the today's talk, I will tell you a small story. Okay. Another manufacturing process, AI in healthcare, Healthify Me, very popular app. Okay. Now you can take help of ChatGPT also. You give the preferences to the ChatGPT and you can generate the, okay. So, but still, I will say these are more focus oriented than the ChatGPT. Camera. All of us are using a mobile camera as a popular tool for clicking the video, recording the video and clicking the photos, right? Do you know that the focusing of that is AI based? Focusing feature is AI based. In some of the high-tech camera, it is also fuzzy is also included because that needs lens to be moved forward and backward. Okay, so focusing is also done with the help of space, which I already mentioned. Okay, so as I said, it is biologically inspired artificial neural network. Some numbers: human brain consists of more than 10 billions of neuron cell. That is the smallest element which is working, capable of carrying the signal. Okay, or I will say computing the signal. Carrying the signal is done by synapse. And again, each neuron is connected with many other neurons. That is another thing. The property of our brain is it can learn continuously until it is healthy, reorganize itself from the experience. As I said, if you are exposed to new environment, new topic, some restructuring will take place. That keeps on doing. It adapts to the environment. Those who are not from Nagpur might be from the north side. The weather is little cool. Still, they are adapted to the current environment. Those who are from the little town, they are adapted to the traffic congestion. Those who are from a very high-tech city, those got adapted to the bad road condition in the Nagpur. Okay, that is what adaptation. And of course, robust and fault tolerant. Robust. Any example? And fault tolerant? If a person suffers a brain stroke, I'm giving a bad example. Okay, and that too transitive. There is a difference. Okay, transitive and permanent. Transitive brain stroke. So transitive means brain stroke आया, क्लॉट था और निकल भी गया. लेकिन ये transitive phase में कुछ ना कुछ part उसने खराब किया. So that patient might lose the control from the eyelid or hand, but after some time it recovers. It is not permanent. Okay. Fault tolerant. Every time some cells are dying, new cells are generating. Okay. So that is another. This is the typical neuron, biological neuron. This is the nucleus. This is the synapse. Okay. So input is received from this dendrites. Then this all inputs are processed by the cell body, and this is nucleus, and then it will generate the output. The synapse will carry this output, and again here it is connected to the rest of the neuron connected here. So these are the recipient neurons connected here. Now, if you look at these connections, each connection is having its own characteristic. So if the signal Y is generated, not all the neurons connected here will get a Y signal. It will be amplified or it will be reduced. Strength of the signal will be enhanced or it might be reduced. It completely depends on the characteristic of this synapse. Okay. So that is the understanding of human being about a biological neuron. Now, if we want to do some kind of computing using this as a base model, we need to convert this into the mathematical model because our computer understands only mathematical model. And if you want to get it done by the with the help of computer, then you have to understand the working of this and convert it into the mathematical model. Okay. So this is the first mathematical model proposed by Mycloch and Fitts. These are the two scientists. Okay. And they simplified. Actually, if you look at the biological structure of a neuron, biological neuron, uh, it is understood by human being that there is some chemical changes takes place which generates the electrical pulse. Okay, and those electrical pulse are carry forwarded from one neuron to another neuron with the connection if one neuron is connected to another neuron. Okay, so again the understanding of human being the uh, about the biological neuron is it generates some electrical signal. Okay, so based on that the microchips develop a mathematical model. Now as I said, the neuron generates the output, and then while passing it on to the another neuron, the connection will have some characteristic. Either it will enhance the signal or it will reduce the. So there are two types of connection, excitatory connection and inhibitory connections, okay, which we call it in a neural network as weights, as weights. Okay. Now, the function of the biological neuron is divided into two parts. This will perform the summation of weighted input, and this will work as a threshold, that is the resistance in the electrical circuit. Nowadays there is okay, we increase or decrease the speed of a fan means what we do from electrical point of view. Actually we adjust the resistance. We want to decrease the speed, we move the knob in such a way that the resistance will increase. Okay, so similarly we can say that this is the resistance offered by that neuron. If the weighted input received by the neuron is greater than this resistance offered by that neuron, then only that neuron will fire, that is it will generate the output, otherwise it will not generate the output. Okay, so this is the basic understanding of the biological neuron. Based on that, the Mycloch and Fitts developed this mathematical model. So simply I can say that mathematically I can say x1, x2, x3 are my inputs. Assume that, though I have not shown here, this is the W1, this is the W2, and the link is W3. Okay, so the first part of the neuron will do a summation of weighted input. So summation of weighted input. Okay, and this is the bias added. Generally W0 is equal to 1. W0, sorry, X0 is equal to 1, and then W0 we need to find out. W0 we need to find out. Okay, so if I want to write down an elaborated equation, it will be W0 X0 plus W1 X1 plus W2 X2 plus W3 X3. If it is greater than the threshold of this neuron, theta, if I say theta, theta is the threshold, resistance offered by that neuron, then only it will generate the output, otherwise it will not generate the output. Okay, so the functionality of the neuron is divided into two parts. One is the adder, which adds all the weighted input. Okay, and then you apply a function, activation function, which is called, that is threshold I said, but every time it cannot be threshold. You, instead of threshold, you can apply variety of activation functions. Okay, So here in this example, the activation function is a threshold unit. Threshold unit is a binary unit. Okay, that is theta is the value of the threshold. If the weighted input is greater than that theta, greater than or equal to that threshold, it will generate 1, otherwise it will generate 0. Okay, when we say 0, this means what? Neuron has not fired. Any doubt in this? How many of you are attending the talk on ANN for the first time? Nobody, right? Shall I? One. Shall I increase the speed? These are the variety of activation function. Again, the neuron is correct. Yes. Yeah, I will come to that point last one. That is why I discuss models. Okay. Uh, Fine. Next. So these are the variety of activation function which you can use depending on your application. If I want a classification task, okay, classification task that is that to two classes. So I can say that for one class it should generate 0, for another class it should generate 1. In that case, I can make use of this threshold. Okay, if I want to design a regression model, that to linear regression model, I will use this linear. Okay, this is a piecewise, this is a sigmoidal. The most popular one is sigmoidal tanh. Okay, and recently with the deep learning, it is ReLU. Okay, ReLU is similar to this of piecewise linear. Only here it is going through the zero, passing through the zero. Okay, and then it is slightly here, not exactly zero, slightly. That is ReLU. As deep learning is one of the separate sessions, so I thought I should refrain myself from discussing all these details. These are the mathematical equation for each one, the linear one, the logistic, that is what I said, tangent, hyperbolic, tangent function. This both will be S. This both will be S. Here the output, input and output will in sigmoidal or logistic, the input and output is clamped between 0 and 1. In the tanh function or hyperbolic tanh function, the input and output is bounded between -1 and +1. Okay, but again the shape will be S. Okay, so as it is I said, it the threshold logic unit will give you output either 0 or 1. Okay, so if I write the equation like this, it gives me the equation of a line. It gives me equation of a line. So if I write down W1 x1 plus W2 x2 is equal to theta, okay, it gives me equation of a line. I can move theta on the left hand side also, so it will become W1 x1 plus W2 x2 minus theta is equal to 0. That is nothing but equation of this line. Okay, and then I can say the all the points which lies below the line belongs to class negative class or class 0, and all the data points which lies above the line belongs to positive class. Fine. It's just a few points about the neural network. Types of the network: feed-forward neural network and recurrent. So this is the case of the feed-forward network. Input is here. You stimulate, you apply the input here. There is a hidden layer and there is output layer. So what the input is passed from input layer to hidden layer. Now this we call it as a synapse or connection. This is characterized by the weight. Weights are nothing but the free parameter. If you remember, I mentioned for designing the model, there are free parameters. You cannot change X, you cannot change Y, that is desired Y, desired output. What you can change is these weights. So ultimately, can I say that I am required to find out the optimal value of the free parameter so that my model with generating y hat should be as close to actual output y. In other words, it should give me the minimum possible least square error. Okay, it should give me the minimum square error. Here, in this case, you will stimulate the network. It will pass on through this synapse or this connection to this hidden. So that signal will remain as it is, or it might be enhanced, it might be reduced depending on the value of the weight here. Okay. Here, the summation of weighted input will be done. Then to that, the activation function will be applied. That activation function is to bring the non-linearity in the neuron. To bring the non-linearity in the neuron. And then the output of the hidden layer is again passed to the output layer neurons. Again, this is characterized by the free weights, free parameter, that is weight. Again, it will get multiplied by the weight. It will add all the weighted inputs. Again, the activation function will be applied to the weighted input, sum of the weighted input, and then the output will be generated here. Okay, so signal is forwarded from input to hidden and hidden to output layer. So it is called feed forward network. This is the recurrent network. In this case, you can see that the output of hidden layer is inputted again. So there are few applications where we make use of the recurrent network. Those who might have studied control system from electrical, when we apply a feedback, it is like a two-edged sword. If you don't apply the feedback properly, the system will become unstable. Okay, so generally we design a non-linear dynamical system by using recurrent network. You can solve traveling salesman problem with this, 8Q problem with this. It is generally used for optimization. Okay, coming to this type of the learning, supervised learning and unsupervised learning. Supervised teacher is there. When I read in 2002, I started reading about the ANN. I was not able to understand where is a teacher. Okay, in all these things, presence of teacher, because literature says so, but the teacher is not a teacher. Your data set, if your data set is having the desired output, so you know that given this input, what should be the desired output? If that is available, you can say that your data is labeled data, and then you can use that data to design a supervised algorithm, supervised learning algorithm. Because by computing the difference between y and y hat is an output generated by the model, whereas y is the desired output. Okay, it generates the error, and based on that error, you can modify the weights. I have simulated that also. Whereas in unsupervised learning, desired output is not available. Desired output is not available. You have only data. X vector is available, Y vector is not available. So in that case, the network will organize itself. So the classic example is classification and clustering. Classification, you know to which class the data point belongs. Whereas for clustering, you don't have the label. So there you need to make use of the clustering algorithm, which comes under the category of the unsupervised learning. See, the data which is labeled, you can remove the data and make it unlabeled. So the data which is available, labeled data which is available, you can design a supervised algorithm also. You can design unsupervised by removing the last column, y vector. Okay, but same is the case not for the unlabeled data. Okay. Then there are 5 learning rules. The most popularly used rule I will mention here is, the first one is the error correction rule, and the second one is the self-organizing map. Okay, so self-organizing map, I said unsupervised learning. Supervised, I said already. Now coming how ANN works. I just simulated one example. This is the data set given. It is a labeled data set because you have labels with you. Data set is having. So this is my X vector and this is my Y. Fine. Now there can be many records. I have shown only 4. I want to design this network. Okay, so what I will do, this is the training data set. I will initialize the weight, all these weights randomly to very small value between 0 and 1. Then I will take the first sample, first data point. I will stimulate the network. मैथमेटिकली एक अरे रहेगा, आप प्रोग्राम से उसको कंप्यूट करोगे वेटेड सम. Okay, one more thing, input neurons are non-computing neurons. So generally I use the word nodes. Okay, because these are like the sensors. They are sensor. They are taking the input and passing it. They are not. They don't have any computing capability. Okay, so they will take this input, will pass on, but these are the free parameters. They have some values that will get multiplied. Okay, and each neuron will receive some weighted input. Then this neuron will compute the sum of the weighted input, and then it will apply the activation function on that sum of weighted input. Okay, and it will generate the output, and that output will be again further passed on to the next neuron present in the next layer. Okay, as I said, it is fed it through to get the output. So I got here 0.8 as output. Whatever the values I have taken, I have not shown here. But actual output is what? Y is what? 0. Your model is generating zero point 0.8. So what is the difference? 0 minus 0 is the y hat is 0.8. So y minus y hat, it is minus 0.8. So now, based on this algorithm, in accordance with some algorithm, I will modify. I will adjust the synaptic weights. I will adjust these free parameters of the network. Okay, which algorithm, how, that we will see later. Okay, I will keep, then I will take another sample. I will stimulate again the network with a new sample, will generate the output. This is the actual output generated with the updated weights. I updated the weights, whereas the actual output is 1. Okay, so again the error is, it should be minus 0.1. Okay, there is a typo. Again, based using this error, I will, in accordance with some algorithm, learning algorithm, I will modify the synaptic weights. And I will keep doing it. I will keep doing it until I get the sum of square error as minimum as possible. As minimum as possible. So this is how the ANN works. So actually what is happening? Assume that this is the data point I wanted to classify. I want to design a classifier for these data points. These data points are not linearly separable. You cannot pass a single line which will classify this data point. So this is non-linear problem. On non-linearly separable data points. I initialize the weight randomly, which gives me this curve. Because of that, I can plot one curve, and this is giving some random curve. Okay. Then I stimulated the network with one data point. It generates the output. It had some error. Using that error, I adjusted the weights. Again, it adjusted that curve. Okay. Again, I stimulated the network. Again, computed error, adjusted weight. It gave me another curve. I will keep doing it. At one point, I will get this curve, which is actually classifying the negative class data point from the positive class data point. Okay, got your answer? We cannot write the equation, mathematical model, why network is generating this output. If we could have able to write it mathematically, then why there is a need of using ANN? Once you train the network, whatever the synaptic values, whatever the pre-parameter values you are getting, you cannot write a mathematical equation forming the relationship between the independent variable and the dependent variable. You cannot formulate the mathematical equation. And that is why ANN is called black box. That is why the ANN is. And let me tell you, with the introduction of deep learning, still last two layers are these layers. So one should salute the researchers who gave this algorithm. We are going to discuss it. It's a error back propagation algorithm. So irrespective whether you are using LSTM, whether you are using CNN or any other GAN, whatever it is, last two layers are these layers. Whenever we design any model, the performance of that model depends on what kind of input you are giving. Okay, if you give raw data, fine. If I little bit process, if I extract some feature from that raw data, and instead of raw data, I give discriminant feature to any model, my output will be better. So always remember, whatever the research is going on, all the PhDs, what they are doing is they are trying to find out discriminative, distinct feature from the given data for the given problem domain, so that I can differentiate these two persons. Why? My brain has already calculated the patterns and it is computing the difference between these two patterns. Okay, again, I'm not carrying a fan. Nobody is carrying a fan on rain. This requires continuous fan. Another property is it is so compact, less than my, okay, does not generate energy, does not dissipate energy. I'm no, so much visual data I'm getting. At the same time, I'm talking, moving, concentrating on the slide. So much data I'm processing, but still I'm not, nobody of us is carrying a fan on the head to cool down our brain. That is another beautiful aspect. The first one is there is another architecture in the feed forward also. There are two categories: single layer and multiple layer. Single layer is only one computing neuron layer will be there. That is output layer. If there is only one computing neuron layer, that is output layer. So if the data is linearly separable, okay, still there is some noise or there is some misclassifications, but still I will say that this linear model can be used to classify the data points from the positive class from the negative class. Okay, and it is presented by Rosenbelt. ANN is having a very beautiful history also. Michael proposed the first mathematical model, I think, in 50s. Okay, but Michael shown that all the logical functions and or can be solved with a Michael model, but for that it was like single neuron to input. So the free value of free parameter they worked out manually with a trial and error. There were no algorithm to find out the values of the free parameter. So there was a little gap. Then Rosenbelt proposed a systematic algorithm, I mean systematic steps, which is also called single layer perceptron algorithm in 1962. So all the big giants in computing field, they thought that, okay, this is the good field to invest money. So they started funding lots of research work. Many money came for the research in ANN. Okay, but then after the paper by Paprit and Minsky, they did the PhD mentioning the limitation of this, and limitation is they can solve only linear problem. As it can, if it is a two-dimensional input, they can generate an equation of a line. If it is a three-dimensional input, they can generate an equation of a plane. If it is an n-dimensional input, they can, this model can generate n minus 1 dimension hyperplane. But it is a plane. It's a linear problem. It's a linear equation. Okay. Then after a few years, they realized that there is no future to ANN. This is the end. After the paper by Papret and Minsky. Okay. But then, so this is one example I will say. And they see just mentioning the algorithm is not sufficient. They have proved it mathematically that why this algorithm will converge, why the algorithm will terminate if you do keep on. So this is perceptron is a simple algorithm which works on the error. So it is called error correcting also, supervised error correcting algorithm. So this is the learning rule. Very simple. This is the old W. This is the learning rate. Learning rate should be greater than 0, less than 1. That how much step size you want to take. And this is the difference between the target value and the actual value generated by the output. That is E. I will say small e. Small e, the error, and multiplied by input vector. Okay. This is only one single updation required in the perceptron learning rule. Nothing else. Okay. So of course, if you look at this term, T minus 1, whenever there is a correct classification, whenever there is a correct classification, what will be the case? Error will be 0. Error will be 0. That is T minus Y will be 0. So this term will be 0. So the weights will not be updated. But whenever there is a misclassification, or whenever there is a difference between the estimated value by the model and the desired value of that data set, then this will be non-zero value. And there the weights will be updated. W dash is nothing but a new weight adjustment applied in the next iteration. Okay, in this way, so this algorithm learns only when there is a misclassification. Okay, this is the algorithm for each training vector pair, that is X is the input and T is the target, that is desired output. Evaluate the output Y. Y is the actual output of the model of the neural network, where X is the input. If it differs, then compute the new weight by this equation. Otherwise, don't do anything. The pattern is classified correctly. Another is the sigmoidal. Activation function is here only the change is this activation function. Now the activation function is continuous. It's a continuous. It is not discrete 0 or 1, plus 1, minus 1. No, it is continuous between. If it is logistic, it is between 0 and 1. 0 will be given for the minus infinity, 1 will be given for the plus infinity. Okay. So some value near 0, some value near 1 for the maximum output. And this is the mathematical equation for the logistic function. Now, here, it is based on the gradient descent. We studied gradient ascent, right, in the 11th standard, if I'm not wrong. Hill climbing problem. Who will reach to the top of the hill in a minimum number of steps? Okay, same is the case. Now, what in this algorithm, what the researchers has done, they converted the problem into optimization problem. Okay, actually, I want to fit a curve which will classify positive data points from the negative data points, negative class data points. Now, I am evaluating the performance of my model using some error measure. Okay, so now I am converting the problem statement into optimization, saying that I want to optimize the error, adjust the free parameter, adjust the free parameter. So what I can do is I can plot the error surface on say x axis and y axis, it will, or z axis, it will be free parameter. For example, there are two parameters, free parameters, and on y axis there will be error. So I will put the value of error for the given value of free parameters. So conversion of line fitting or curve fitting problem to the optimization by the gradient descent. I will not talk much about the mathematical aspect. One is the local gradient. Here the error is computed. Now error is 1 by 2 TP minus, that is target minus actual output of the model, whole square. Squaring is for nullifying, right? Nullifying the sign. And then I am computing the gradient of this error with respect to the free parameter. With respect to the free parameter. Okay. And then that gradient gives me in which direction I should move the weight vector so that in next iteration my error will decrease. So this is the final equation of weight updation. Now the challenge in the hidden multi-layer perceptron is We know the output, desired output for the output layer neuron. What about the hidden layer neurons? What about the hidden layers? Because for hidden layers, there is no desired output available. Okay, so there we apply the credit assignment problem. Credit assignment problem is like we want to organize some event. For that, one will be the chairperson of that committee, and then there will be a subcommittee, and for every subcommittee, there will be one in charge. So if that event goes very good, or it brings some financial aid, then everybody will have a share depending on the contribution. If it is does not went well, if you go into the loss, then all the committee members should be punished, okay, in proportion to their contribution towards that event. So that is what the credit assignment problem. So though the name is error back propagation, it is not a recurrent network. Here, fine. Input is given to the hidden layer. Okay. Then it is passed here. Here only you have a desired output. You will compute the error here. Based on this error, you will compute this updation. Okay. Now, these updation will be computed. Assume that there is one more neuron here. Now, these neurons are also connected to one more neuron. So while computing this local gradient, we need, because the output of this neuron is inputted not only to this, but another neuron present in the output layer also. So while computing the local gradient for this, I will take into consideration the error occurred in all the neurons to which the output of these neurons are inputted, and not only one neuron. So in a backward direction, you are giving the responsibility to each neuron, how much they shouldered towards whatever the error incurred in the individual neuron present in the output layer. So I don't know whether it is there or not. It is not included, but if you look at any literature where the derivation is given for computing the local gradient for this layer or weight adjustment for this layer, you will find that error incurred here will help in computing the local gradient in both the neurons, and that will be taken into consideration while updating this all summation of all the local gradients and not only one neuron. Okay, whereas if you compute the local gradient here, this will be updated based on this. This will be updated based on this, whereas this will be updated based on all this. That is the credit assignment problem. Here it can be seen. Summation of local gradient at the hidden layer when you are updating the links from the input layer to hidden layer. So summation of summation. This tells you that it takes into account the error occurred in all these output layer neurons. So not to get confused in the name, that is error back propagation, no computing signal is back propagated. Only while computing the responsibility, awards or punishment, that error signal is in the form of the local gradient. It is backfeeded from the output layer neuron to the input. So during the second pass, whatever the error is computed is used to compute the local gradient here, and this local gradient computed at the output layer neuron is used to compute the local gradient at the hidden layer neurons. So that way the error is back propagated and not the computational functional signal is back propagated, not to get confused with the term error back propagation algorithm. The network is feed forward network. Network is feed forward network. So that is for say propagate activation function from one input to output in the backward propagates error from output to hidden in the form of local gradient. This is the algorithm. So the point I want to press over here is weight learning algorithm of NN is jump. You keep on modifying, it will allow you to keep on modifying. It goes into thousands and thousands of tiny adjustments. Again, as I said, when we talk about the gradient descent, it is like a optimization problem. In optimization problem, there is a error surface. Though I am showing that error surface so smoothly, but error surface is not so smooth. It is having some ups and downs. And when we talk about the optimization problem, there can be a local minima, there can be a global minima. So it might happen that your algorithm gets stuck up in the local minima. Okay? And there are some saddle point also that for a few iterations you will feel that this is what the solution, because weights are not updating, error is not changing. But if you keep on doing something, it will get out of that. That is called saddle point. But we keep on training the network. That is, updating the weight is nothing but a training the network in a hope that it will land to the global minima and not the local minima. But then, as we are initializing the weights randomly, the solution to that is we should not go only for one model. For the same problem statement, we should develop more than one model, say 2, 3, 4, and initialize the weight randomly for every iteration. So the starting point will be different for every model. So it might happen that for some model, it will not get stuck up in the local minima, and eventually you will reach to the global minima. But again, it is a trial and error. It is a trial and error. So this is very popular data set, MNST, MNST data set, where handwritten digits are given. So what actually the hidden layer is doing? We know that, we introduce the hidden layer because the limitation of the single layer perceptron is it can handle only linearly separable data. It cannot handle the non-linearly separable data. So what the hidden layer does? Hidden layer helps in extracting the features. Sometimes it also helps in extracting the statistical feature. Okay, if it's a visual pattern, then you can see that it helps in extracting these types of feature because it is this strong weights. This means that it is extracting this feature, this neuron typically, which I have shown here. Okay, if I look at the synaptic connection, so I got that it is something like this. That is, blue color connections are the strong. So it is extracting this feature. And beautifully it is extracting those features in unsupervised way. You are not telling them the neuron network or that neuron in the hidden layer that extract this pattern. Okay, this pattern is characterized by 0 0 0 1 1 1 0. Okay, that is a pattern. But you never explicitly mention to the set of this neuron to this neuron that only see the pattern where the first 3 pixels are 0, then 3 pixels are on, and again then one more pixel is off. You are not telling that. You are not giving the pattern to be extracted. It will, over the training, it will get self-tuned. So, and we came to know that it is extracting this feature. So another can be extracting another feature, this feature, this feature, okay, which is representing something like this, and so on. So hidden layer try to extract the feature in unsupervised way, in unsupervised. Actually, why deep learning became very popular after 2010? What was the scenario before 2010? Anyone? Especially for image data. Especially for image data. Why it becomes so popular? Before 2010, or I will say 2006, the scientists used to handcraft the features given the image. Every data set, image data set will have some domain, natural images or animal images or no infrastructure images or sea images, fish images. So those set of images will have some characteristic. So the researchers who want to design a classification algorithm or clustering algorithm used to study about those images, used to extract that is no image features, and using those image feature they used to construct the feature vector, and then that feature vector is inputted to the neural network. So ultimately the performance of the neural network or any machine learning algorithm heavily depend on how you construct the feature vector. If the feature vector is not beautifully designed, beautifully means what? I want to classify, right? I want to classify the data into two classes. So I want a distinct discriminative feature which are different for two different classes. If they are overlapping, I cannot make use of those feature for classifying, right? I want to find out those feature which are present in one class and not present in another class. That is what discriminative distinct feature. Okay, so researchers used to handcraft those features, used to construct the feature vector for the given images, and then that feature handcrafted feature vector is inputted to the machine learning algorithm. So the performance of that machine learning algorithm heavily depends on the extracted feature, and that is based on the knowledge of the person working on that. Whereas with the introduction of CNN, this part this part is beautifully done by CNN. This part is beautifully done by CNN. And then this dense network, that is error backpropagation algorithm, is used towards the end of the network just to classify. Because now a very beautiful feature vector is constructed with the help of CNN. Now that vector is inputted to the dense network, which makes use of the error backpropagation algorithm, and then it will classify. And that is why the accuracy of those system improvise majorly. So this is what some of the hidden neurons identify this pattern, some neuron identify this pattern, and so on. And together, these extracted features are inputted to the output layer neuron, which helps in classifying the data. This is what the output layer neuron. Again, if you have multiple hidden layers, so I can say that the first hidden layer is extracting this feature, the second hidden layer neuron is extracting that whether this, and this feature is present together, then it belongs to a particular class. Then it belongs to particular class. Again, the size of the input and size of the output depends completely on the data set and the problem domain. Here, I want to classify the handwritten decimal digits. I know that it's a decimal digit, varies from 0 to 9, so number of classes will be 10. Okay, and the input size depend on the size of the image. So this means that if I keep adding the layers, my network should perform better and better. Yes or no? Why? If I'm saying that I'm praising the hidden layer, it is helping me in extracting the features which are discriminative and distinct. Yes? Anyone? Then I should keep adding the no, hidden layers between the input and output layer. Just now I praised, right? It helps me in extracting all those features. The first hidden layer is extracting the small features. Small features are more generalized. Using those small feature, I am constructing the larger feature, which is little less generalized, unique, and so on. So I should keep increasing the hidden layers. Is it so? Because brain is designed like that. And it is motivated from the biological neuron, right? Brain. So I should do that. Hmm? Anyone? There are many problems. There is a concept of overfitting and underfitting. I will not mention that. But before going ahead, we are using gradient descent. Gradient descent. Whatever the error incurred in the output layer, I'm taking help of that error to compute the local gradient in the output layer neuron. So I'm using that directly. Okay? With some proportion, I am modifying that there is a eta learning rate which varies between more than 0, less than 1. 0 होगा तो learning कुछ नहीं होगा. When I come to the hidden layer, the local gradient computed in the output layer is used to compute the local gradient of all the neurons in the hidden layer. Or it's a gradient. Gradient will be always very small. It will be always very small. Okay. So if I keep computing, here I computed local gradient, I pass on this to compute the local gradient here, then local gradient here, then local gradient here, local gradient here. Okay, when I will compute the local gradient here, it will take into account all these local gradients, multiply, multiply, multiply. All are less than 1. What will happen? If I multiply two values, say 0.2, 0.2, how much I get? 0.04. If I multiply 0.0, 0.04, 0.04, how much I will get? 0.0016. So when it reaches towards the input layer, the value of gradient becomes very small, very, very small. Okay, and my weight updation is heavily dependent on that local gradient. If that local gradient becomes very, very small, will the learning takes place here? No, hardly any learning will take place. This problem is called vanishing gradient problem. This problem is called vanishing gradient problem. And that is why deep networks are designed. Those deep networks are divided into two parts. The first part, like if I am using for classification of the images, the first part will be CNN, and last part will be a dense network where two hidden layer and one output layer will be sufficient for me to classify, because my now feature vector is beautifully designed. Okay, the input to the dense network is having a very discriminative distinct feature. Now it is very easy for my network, which is having two hidden layer and one output layer, to classify those patterns either into two classes or the multiple classes depending on the problem statement. Out of the many problems, this is one problem of the multi-layer perceptron, and that's why again there was a slag between when the MLP was introduced and when in 2010 the Google paper was published, which makes use of the, because you cannot increase the layer here because of the vanishing gradient, right? In hoping that the performance will improve. No, performance will not improve. Got the point? So there are many design issues, many optimization techniques we can apply. One is optimization for the free parameter, which we have done. When we discuss, I just mentioned, this is a 1 semester course, right? So trying to combine it in a 2 hour. So how you adjust the weights? Then there is no ground rule that how many neurons. As I said, the problem statement will tell you that how many neurons should be there in the input layer and output layer. But what about the hidden layers? Okay, if it is an English alphabet character classification, I know the output neuron is going to be 26 because it is having a 26 characters. Okay, that is problem domain dependent. But what about the hidden layer neurons? Okay, so you need to work out, there are various methods to work out on that. how you want to represent the data. Many a data is categorical data. Many a data is a, no. For example, if I want to do some kind of study of particular section, my age will vary from 1 to 100, whereas salary in thousands. So if one figure, one parameter figure is heavy, it will dominate the complete design of the model. So I should normalize the data. Okay, so that pre-processing and everything, then the size. Of course, all ANN based algorithms are data hungry. If data is available, then only you can think of making use of these models. Otherwise not. And that is what nowadays machine transformation is working, no, very popular. It is adaptive, generalization ability is there. It is fault tolerant. And few classical architectures are single layer, I already mentioned, multiple layer. Kohanon is a self-organizing, unsupervised network. And actually, CNN is comes under the category of the shared weights. Here, the weights are not at all shared. Each neuron is connected to all other neurons present in the previous layer, present in the next layer. And you can drop few connections also, but again, it will be tuning of the. So classification, just I will go through it. Task. One of the very popular, if those who are doing it for the first time can search for this data set. It is available, I think, on UCI machine, both the data sets, mushroom and iris. The typical attributes for mushroom is this. The values are something like this, which is categorical data. You can convert it into numerical data. For iris, I prefer the first reference, neural network, a comprehensive foundation by Simon Hacking. My complete content of this class depends taken from that book. Okay, best book. English is little difficult to understand for the first time, more mathematical, but once you understand, it will be you will remember throughout your life. The second one is a popular one. Most of us might be using that, pattern recognition by Bishop. If you look at the books written by Rosenberg, they never use the term artificial neural network. The title of the book is Distributed Parallel Computing. Distributed Parallel Computing. And now you can justify these terms. I saw most of us solve the mathematical numericals by while listening to the music. I'm making you to understand something at the same time you are trying to take notes, trying to click the photographs of the screen. Parallel computing, distributed. You're moving your hand. Signals are also generated from here. Okay, so many parallel things we are doing. We are moving our eyeballs, moving your eyelids. Okay, distributed, anyone? Why distributed? Distributed. Not all the neurons are doing all the tasks. It is again divided into region, visual, audio, no frontal be here, sidal. So if again I will give the same bad example, the person who suffers the brain stroke, a part of the brain dead, okay, but still one part of the body is working. This shows that it is distributed. Okay, short-term memory loss, but rest of the brain is working. That is what distributed. Some part of the brain is not working, doesn't mean that the complete brain is not working. Okay, so the tasks are distributed. So same is the case for the artificial neural network. If some connection goes down, if some neuron goes down, doesn't mean that the complete network will not work. One machine can do work of 50 ordinary man, but no machine can do work of an one extraordinary man. I will end with a short story. It's a very old story. There was a manufacturing company who used to manufacture some biscuit or something like that, and they tried to automate the packaging system. So in the packaging system, there was an assembly belt. Biscuit used to get somewhere, then they would wrap. But after designing the system, when they install the system and they put it into the work, they realize that some of the boxes they are getting as output are empty. They are not filled because those small packets of the biscuits are packed in a box. Then CEO was called because it was a big project. Many managers, design architect of that system was involved, programming IT personnel were into. They tried to modify the system, but they could not get hold on that error. So they decided that we can add one more unit, that is a weighing unit, okay? And if the weight of the box is low, about some threshold, the assembly line will stop. That assembly line will stop. And then the person, they depute one man, they employed one man hour, and then that person will come pick up the box and will keep aside. And again, he will start that assembly line. Okay. After a few days, the person who deputed there, a laborer who deputed there, he realized that every time the box is empty, that machine will beep, the assembly line will stop. I have to get up from my chair, walk to that place. He might also be assigned some another work. Okay, they will not put him idle. They are paying to the laborer. I have to take out that box, keep it other side. तो इट इज वेरी टीडियस एंड टाइम कंज्यूमिंग मेरा हाथ का काम छोड़ के मुझे यहाँ आना पड़ रहा है वो बॉक्स सिर्फ बॉक्स उठाने के लिए सो व्हाट ही माइट हैव डन एनी सॉल्यूशन टू दिस he was having one what you can say fan वो स्टैंड वाला फैन जो होता है and he adjusted his sitting location in such a way that the fan was on opposite side and assembly line was in between. So whenever the box was empty, fan was pushing it out of the assembly line. So it is not necessary every time some sophisticated solution is required. But that person thought out of the box, not typically from technical point of view कि कहाँ sensor खराब है क्या नहीं है, what went wrong in the assembly line design. He applied very small thing and he got the solution. Okay, so always don't depend on the machine or AI. There can be some another solution which we can work out. But only the out of box thinking is required. Thanks for your patient listening. Any questions? After 2 hours, I don't think.
There will be many questions regarding today's topic. Hopefully, the lecture was so good and delivered in very easy manner so that each and every point and topic is clear to each and every participant. How layer by layer making the ANN, RNN works. Thank you so much, ma'am, for such a valuable knowledge. Hopefully, we will definitely get benefit out of it from today's session. Thank you so much, ma'am.
Thank you. You cannot. You cannot. That is what I said. We need to only generating one model is not sufficient. Model means what? Value of free parameters, synaptic connections, right? We generate one model, we save that model. Again, we reinitialize the weights. Program is there. Only you have to run that program. Okay. Then again run that, and whenever we design a model, we compute the error also. We measure the performance either in terms of accuracy or mean square error, whatever you measure performance measurement tool you are using. Okay, we do it for 2-3 times, and then if at all you can compare with all these generated models. We cannot. It's a blind process. Okay, if you give me pen, actually I teach something like this. See that error surface. For example, I have a two free parameters, say W0 and W1. I prefer teaching on board. This is challenge for me presentation. Is it working or not? And this I will say error, E average, mean square error. For example, I am plotting it. I am graphically plotting. So for every pair of W0 and W1, my model will give E average, some value of E average. Okay. So as we randomly initialize the weights, it will be somewhere high. It will be somewhere high. Okay. And then slowly using the gradient descent. So actually what we assume is, assume that there is some surface, something like this. No pen is working. There is some surface. Okay. Now to our hard luck, if there is a minimum local minima here, then your model will get stuck here. Okay. Randomly, if you start from here, there is no local minima. You might reach to this global minima then. So it because the error surface stressed by your model depends on your initials, not only the initial initialization, but also the size of the step. Okay. Now there are and again there is a optimization technique applied for this eta. Eta is a step size, na? Eta is a step size. So at the start of the training, I know I am far away. My model is far away from the ideal solution. So there I can I can dare to take a larger steps. आपको यहाँ से अमरावती के सीओई में जाना है. फर्स्ट स्क्वायर आते तक आपका स्पीड अच्छा रहेगा गाड़ी का. As you reach to the nearer, you assume that you don't have a Google map. Okay, you will slow down your speed. You will inquire where is the COEP, where is the COEP, where is the COEP. जैसे ही आप पास में आओगे आप और स्पीड कम करोगे. Same logic here. You start with a bigger step here. As you progress, you reduce the size of the step so that you should not miss the minima. Otherwise क्या होता है कि आप यहाँ पहुंच जाते हो, फिर वो यहाँ आता है, फिर यहाँ आता है, फिर यहाँ आता है, तो उसको यहाँ आने के लिए टाइम लगता है. That is another optimization which we apply for the eta. So black box, ANN is a black box. You cannot, after generating the model, you cannot express it in a mathematical model. Okay, once you can apply, I mean, you can come up with a mathematical model, there is no need of applying AI. AI is applied only to those problems where our understanding is limited, the problem is very complex, and we cannot express the relationship between input, that is independent variable, and dependent variable. Then there is a concept of cross validation and so on. There are many other detailed points, detailed discussions. Any other question? So in this way, it becomes an optimization problem that we want to reduce the E average, mean square error, in the search of this minima. Fine.
Thank you once again, ma'am, for such a wonderful session, and hopefully we can help to resolve more issues. So with this, we will conclude this session, and just after this, the article discussion is there. As we yesterday, we have already reviewed papers, articles with you, okay? And based on that, we have to discuss. PPT is required to prepare group by group, and you have to summarize. In summarized way, you have to discuss in front of all the participants. Right? So, if it is required, we will take a break for 5 minutes, and we will resume after 5 minutes and continue the session. Thank you.
I will leave. मॅडमशी भेटते आणि निघते मी. ठीक आहे. माझं पेनड्राईव्ह. मॅडमला मी ऑलरेडी PDF पाठवलेला. अच्छा.